Calculus Algebra Review Section 5, Fractional Exponential Notation and Square Roots. This is really important and a lot of people do not have intuition on this. So we're going to be delving into rewriting expressions that don't have powers with powers, because in calculus it's so much easier to not have simple symbols and to instead have powers. So we're going to be moving that direction. First of all, some things that aren't fractional exponential notation that a lot of times people think are fractional. Something like 1 over x squared. If I was to rewrite this guy in terms of just an expression with a power, like a x to the power of sort of function, I'd just write this as x to the negative 2. If we change the sign of the power, we're allowed to flip it in the fraction. Similarly, if I have something like x to the 4th and I wanted to have a fraction, which I don't really know of many situations where this is that applicable, but if I wanted to rewrite this guy, x to the 4th, I could write it as 1 over x to the minus 4. Now, if you're like, what does this look like? Well, really it looks like this. X to the minus 4 is 1 over. So it's 1 over x to the 4th. And I mean, we can plug an easy number. 2 to the 4th is 16. Let's see if we get 16 out of this. We get 1 over 16, because we said x to the 4th is 16. If we divide 1 by something that is 1/16th, we're going to get 16 out of that. So that's legit. So negative powers flip fractions. Now, where we're moving towards is fractional powers. Fractional powers come from square roots. That's why I call it fractional exponential notation and square roots. So if I have something like the square root of x cubed minus 16, I can just rewrite this as x cubed minus 16 to the 1/2 power. And this is way nicer to do calculus on, because with calculus we affect things like the exponent here. And so having it written in this form is so much more useful than having it written in this form. Let's delve into more of this. The cubed root of x to the 7th minus 6. I'm just making up random things to plug inside. This would just be x to the 7th minus 6 to the cubed root means to the 1/3 power. So whatever number's here in our root is always the fraction of our power. So if we have, for example, like the 8th root of x squared plus 1, then we just have x squared plus 1 to the 1/8. But we don't just have 1 over sort of situations. A lot of times in calculus we have stuff like x to the 6/7. And if I want to go backwards and write the function in like this sort of form with roots and stuff of this, I need to like understand what these things are. So this means I'm raising it to the 6th power, and this means I'm taking the 7th root. So I just got to draw both of those things. So there's two ways to do this. One way, x to the 6th, and I just 7th root it like that. And the other way is the 7th root of x to the 6th power. And it actually doesn't matter which one I do, because they're the same. In both of them, I'm raising it to the 6th, and in both of them, I'm 7th rooting it. So, for example, if I have something like x squared minus 7 to the 8th power, and we're 13th rooting it, this would just be x squared, I should make that clear, x squared minus 7 to the 8/13. Which seems horrible, but the calculus on stuff like this is pretty easy. As long as we know what that number is, we're in good shape. Alright, we have added things like what is 1 over the cubed root of x to the 9th plus 1. Well, I got the 1 over situation, so I'm actually back to the beginning here where I have the negative power, but I also have a cubed root, so I have this sort of thing, a 1/3 power. So really, this is just x to the 9th plus 1 to the negative, because I'm flipped over, 1/3. So if somebody gave me x to the x squared minus 3 to the negative 6 over 11 power, and I was supposed to rewrite this in terms of a form like this, well, negative means 1 over, so I've already done 1 over, and then I just need to do the 6/11th power. So 1 over x squared minus 3. Do I want to root first, or do I want to power? I'll power first to the 6, and then I'll 11th root this. And that's how fractional exponents work.